All right, so today we're going to talk about how to calculate a geometric series. So remember the difference between a sequence and a series is a list that follows a rule or a pattern, and a series is when we want to find a sum of a bunch of numbers in that list. So for instance, I'll throw up the first example here. If we had the numbers 7, 14, 28, 56, etc., and so this has our nice geometric pattern where they are multiplying to go from one to the next. So in this case, they're multiplying by 2 over and over again. And so we have a common ratio, of 2. So R is positive 2. Okay, so it is geometric, but we're trying to add a bunch of terms, and this particular question wants us to find the sum of the first 12 terms. Okay, now could I just continue to generate 8 more terms as they get bigger and bigger and then add all of them up in my calculator? Yeah, we could probably get the same sum that way. But imagine if it wanted me to do the first 25 terms, that would take a long time, and these numbers get really, really big. So we do have a formula. It's actually a pretty complex looking formula, but we're really just going to plug numbers into the formula as is, and then I'll show you how to plug that into your calculator or into Desmos. Okay, so the formula to find the sum of the first n terms of a geometric series, so this is a different formula than the arithmetic ones. The sum of the first n terms equals the first term times this whole big fraction of 1 minus the common ratio to the n power. And it's important to put this common ratio in parentheses, especially if it ends up being a negative common ratio, over 1 minus the common ratio. Okay, so lots of stuff going on in there. Here again, I just explained what those terms mean. S of n, the first term, n is the number of terms or the position of the last term, and r is the common ratio. So we need 3 things to find our sum: the first term, the common ratio, and the number of terms. First term, common ratio, and the number of terms. Okay, so let's make sure, of course, we have all 3 things, and I think for most of our problems today, we will. Okay, so we need to find our first term, which we have. It's 7, right? That's the value of our first term. Next, we need to know our common ratio, what our pattern is that we're multiplying by. And again, remember, if you're having a hard time figuring out what that common ratio is, that r can be found by taking any term, so let's say 28, and dividing it by the previous term. So r equals any term divided by the previous term, and reducing this fraction gets you 2 over 1. So our common ratio is 2, which we kind of figured out earlier. Now sometimes you can kind of eyeball it, that they're multiplying by 2 over and over again, therefore r is 2. Okay, but we got our second value, and then our number of terms. Well, it did tell us here to find the first 12 terms. So they actually did, in verbiage, tell us the number of terms we're searching for. Okay, so we're going to start plugging in to the formula here. The sum of the first n terms, the sum of the first 12 terms, equals our first term, which is 7, times, and we're going to have a big fraction here, 1 minus, so 1 minus, parentheses, r to the n power. So it's r, which is 2, to the n power, which is the 12th power, because we're finding 12 terms out here, over 1 minus r. Okay, now this is a lot of stuff to compute by hand. You could do that, but let's not, because we're gonna make less mistakes if we don't. Okay, so now I'm gonna pull up a calculator for our purposes. I'll pull up the Desmos Calculator. Okay, so here is the Desmos Calculator. So the first one we're gonna type in is that 7 in front, 7, and we're gonna press times, and then we're gonna start some parentheses. Now to build this fraction, there's a fraction key right here, a over b. And in the top, we're going to type 1 minus, don't forget the parentheses around your common ratio, so parentheses 2. And then to raise it to a power, you can press this button, or you can use Shift 6. We'll also get you up into our exponent. So now I'm going to press down to get in the denominator 1 minus our common ratio. And so here, I could of course close my outer parentheses, But here is our answer. If you kept generating that pattern, you got 8 more terms, you had a total of 12, and you added them all up. As those numbers got bigger and bigger and bigger, our sum is 28,665. 28,665 is the sum of the first 12 terms. Now, again, could you check that manually by calculating 8 more terms and adding them all up? Absolutely. But it's nice to have a formula that will save us time, especially when we can just plug it into a calculator and have it do all those complicated calculations for us. Okay, so we've got a few more examples, just 2 more here, and I've just copied the formula over and our checklist over. Otherwise, there's not much new stuff to write down here. Okay, so let's go through to find the sum of the first n terms of the geometric series. So they told me it's geometric, we don't have to check, but let's go through and see if we have all that we need. We need the first term. Check, our first term happens to be 1. We need the common ratio. What are they multiplying by to go to the next term? And this pattern is a little more obvious than some other ones. I think we're multiplying by 5, right? 5 quarters is $1.25, and so R here is 5. Now again, remember you can always find the common ratio by taking any term and dividing it by the previous term. So 25 over 5. Which does simplify to 5. So that's an alternate way of finding it when it's not as obvious. Okay, we got the common ratio. It's positive 5. Next, we need to know how many terms we're adding up. And here, it actually just told us n is 11. So we're adding up the first 11 terms. Okay, so now we can go to our formula and start plugging in. The sum of the first 11 terms equals the first term, which is 1, times our parentheses in this big fraction in here, 1 minus the common ratio in parentheses to the nth power, so to the 11th power, all over 1 minus the common ratio. Now again, rather than calculating that all by hand, let's go to our calculator. Okay, so once again, now the 1 times in front, probably didn't have to put that in this time, but just for good measure, now we'll press our fraction key. So we can create this fraction in our parentheses. 1 minus, open parentheses, 5. Either Shift 6 or this button right here is your exponent key. So to the 11th power over, get into the denominator there, 1 minus 5. And look how big this is. Wow. We got into the millions, 12,207,031. 12,207,207, that's a 2, 31. Wow, if you generate 11 terms now, keep in mind that list is going to get pretty large pretty quickly when you continually to multiply by 5. That kind of exponential growth is huge. So very, very large number, 12,207,031. Okay, so let's try one final example here. Our common ratio will be a little more complex, but let's see if we have all we need. Find the sum of the first n terms of this geometric series. So again, they've told me it's geometric, so I know I can always calculate r if it's not very obvious. Now my numbers are getting smaller, so I'm guessing they're multiplying by a fraction that's less than 1. So again, a nice way of finding it is let's pick the easiest numbers in here. So it's going to be a little tougher to tell this time. We can take any number and divide it by the previous term. So I'm picking the smallest 2 they gave us just to work with smaller, simpler numbers. Okay, well a positive divided by a negative will be negative. And in fact, you can divide each by 32. 32 goes into both. And it ends up, my common ratio, what they're multiplying by over and over again, is negative 1/2. And you can put that negative sign in the top, the bottom, or in front of your fraction there. But we have our common ratio. We do have the first term, negative 256. We do need to keep the sign with it. And how many terms? This time it's 10. So 10 terms. Now we can plug in to our formula. So the sum of the first 10 terms equals the first term, negative 256, times parentheses, big fraction here, 1 minus the common ratio, which is negative 1/2, and you would definitely need the parentheses here because it's a negative number, to the 10th power. That's okay, I'll show you how to write this fraction in Desmos, over 1 minus the common ratio, negative 1/2. So you could put parentheses there if you'd like as well. All right, here's what we need to type in Desmos. All right, negative 256 times parentheses. Press our fraction key here. 1 minus parentheses, negative 1 divided by 2. So you can either press the fraction key or I just press divided by 2, the / on your keyboard. Close those parentheses. That is raised to the 10th power. So make sure you get up in your exponent, use the exponent key or shift 6. And in the bottom we have 1 minus negative 1/2. So if you want, you could put parentheses there. The calculator, of course, will know what to do with minus and negative. And so here we go. It ends up giving me a decimal. And if you want, you can press this button to convert to a fraction. It will do that for some decimals. So either negative 170.5 or negative 341 over 2. 41 over 2 or negative 170.5 is the sum of the first 10 terms of that geometric series. Okay, so as long as we have all of our information, we just need to plug into our formula, right? Don't necessarily try to calculate all of these little things by hand. Let your calculator do the hard work. All we need to do is practice making sure we can put this whole thing in all as one. Okay, we'll run through some more examples. We'll also do review of previous units in class.